Welcome back, gang. So let's take a look at our next example. We're now going to graph equations by plotting points. So for each equation, find at least 3 ordered pairs that are solutions. Use the points to graph the equations. So in example 2, we're going to graph 3 equations, and we're going to do it solely by hand. No calculators, no technology. And then in example 3, I'm going to show you how your calculator or how technology could have assisted you in doing this. I'll never take away technology from you. So you'll have that through every exam, every homework. But I also think it's just a good exercise to go through graphing these by hand. So if you ever run across an equation and you're like, darn it, I don't know how to graph it, this technique will always work. It might take you a little while to do it, and it won't be as fast as technology, but it'll always work. So if I take a look at this equation, we've got y equaling 4x minus 1. And some of you might recognize this as a line. You might be like, oh, you know what, Miss A? I know the slope's 4, y-intercept 0, negative 1. I'm going to call it a day. You could totally do that. But let's say it's been a minute, right? And you're like, darn it, I don't remember how to graph this. Well, this is how you find your 3 ordered pairs that are solutions. And when I say solutions, that means the x and the y coordinate fit in this equation. So when it comes to finding 3 ordered pairs, I'm even going to go a little further. I like to find 5 ordered pairs, but we'll start with 3. And my basic set of 5 that I do, and you're always going to pick your x coordinates because x is your independent variable. I usually get these 5 x coordinates as my basics. All right, now as we move throughout the semester, I won't always choose negative 2, negative 1, 0, 1, and 2. But I will choose them a lot of the time. Okay, sometimes we'll be shifting things left, right, up, down, and I'll mess around with what I pick for my x values. But for most basic functions, those are my 5 starting x values. Now from here, let's find their solutions. Let's find their corresponding y coordinates so that we can make an ordered pair that's a solution. So if x is negative 2, let's plug this in for x, and we're going to do some mental math. So we got 4 times negative 2 is negative 8. Negative 8 minus 1 is negative 9. Right, so I'm plugging x into my equation. Now I'm going to plug x being negative 1. 4 times negative 1 is negative 4. Negative 4 minus 1 is negative 5. All right, and if it's hard to hear me say this, I'm quite literally plugging this in. Y would equal 4 times negative 2 minus 1, which is negative 9. Over here, y would equal 4 times negative 1 minus 1, which is negative 5. All right, let's plug in 0. 4 times 0 is 0. 0 minus 1, negative 1. Right? 4 times 1 is 4. 4 minus 1 is 3. And last but not least, 4 times 2 is 8. 8 minus 1 is 7. So I actually have 5 ordered pairs. And these are all solutions because if I plugged x being negative 2 and y being negative 9 into this equation, equality holds. So that means it's a solution. But I can also graph it on my Cartesian coordinate system. So let's have a chat about what I'll be looking for when you go to graph an equation for me on a test. The first thing I will always look for is that you label your x and y. All right, you need to tell me, or you need to communicate, hey, I know x is the horizontal axis, y is the vertical axis. The next thing you need to let me know is you need to tell me how much each of these squares count for. What is the scale? So are you going to let your squares equal 1 unit? 2 units, 10 units? Do you want to label this or scale this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Do you want to go 2, 4, 6, 8, 10? You can decide. And you don't even have to have them be the same numbers. You could scale the x-axis by 2s and the y's by 1s. But just looking at the numbers I have in front of me, it looks like on the x-axis I'm going from negative 2 to 2. And from the y-axis, I'm going negative 9 to 7. So I actually need a little bit of room on my y-axis, right? Got to go from a y of negative 9 up to a y of 7. And I don't have to do that much in the x direction, just negative 2 to 2. So I'm going to go by 1 unit. So I'll make each of these 1 unit. Okay, so 1, 2, 3, 4. I'll scale this at 5. This one will be 10. All right. And then I'll make each square here 1 unit. So we'll go 5 here, 10 here. And this will be your basic Cartesian coordinate system that I give you. It's always going to be 11 units in either direction. So there's 11 squares this way from the origin, 11 up, 11 back, and 11 down. All right, let's put some ordered pairs on here. So we've got negative 2, and then if I go negative 9, I'm going to come up this way. And then we've got negative 1, 1, 2, 3, 4, 5. I've got 0, -1. I've got 1, 3, 2, 3, 4, and 2, 7. So taking a look at that, I can see the line in here. Okay. So there we go. That's the graph of that equation, right? So for each equation, I did find 3 ordered pairs, and I used those points to graph the equation. Now, just for fun, just to kind of give you a preview of where we're going, let's see if you remember terms, and this is, I'm gonna just put this off to the side here. I'll put a little bubble around it. All right, we'll call this our first note together. Do we remember something called a domain and a range? All right, and I just wanna review these concepts. We'll pick them up officially at a later section, but the domain. What the domain talks about is all the different x values that you can plug in, right? So now you can see in the x direction, I have this line going to the left forever, right? This is going down and left forever. And then on this side, it's going up and right forever. So you can see this line is moving all the way to the left and all the way to the right. And x's are always left-right situations. X's are always horizontal, y's are always vertical. So since I can move all the way from the left side of the x-axis to the right side of the x-axis, I would say my domain went from -infinity to infinity. Or some of you in the past might have written all real numbers. All right, or maybe some of you even use this symbol for all real numbers. All right, and if you haven't seen that before, don't fret too much. We will discuss it at a later section. I just want to kind of give you a preview. Now, range is all the y's that you can do. So you can see my graph goes from all the way down to all the way up, right? My y values, you can see that arrow heading all the way down forever, this arrow going all the way up forever. So I go from -infinity to +infinity in the y direction. Same way I went, well, not the same way, but I also, again, just reviewing, we went all the way to the left, all the way to the right in the x direction. So again, x's are always left, right, y's are always up, down. And we always write them from lowest to highest. So I went from all the way down to all the way up. That was my range. And we would say, again, that was -infinity to infinity, all real numbers. Or maybe some of you have written it that way. Okay. All right, so with that, I'm going to flip to the next page and we're going to graph a different function. I'll see you in a few. Bye. Okay, let's take a look at this next graph. Some of you might recognize it as a parabola. And again, that might just be too far on the distance in your memory to recall right now. No problem. If all else fails, if you don't see this as a parabola, then try some test points. And just like example 1, I'm going to try my favorite 5 test points, -2, -1, 0, 1, and 2. And we're always picking the x coordinate first because x is always our independent variable. You pick x, and then based on what you pick for x, you plug it into this equation and you get your y back out. All right, so let's see what we're going to get here. So I need to plug in x being -2. I'm going to do a little mental math first. So we're going to go -2 squared is 4. 4 minus 4 is 0. Okay? Let's try -1. -1 squared is 1. 1 minus 3, 1 minus 4 is -3. Okay, 0. 0 squared is 0. 0 minus 4 is -4. All right, 1. 1 squared is 1. 1 minus 4, -3. And then 2 squared is 4. 4 minus 4, 0. All right, so I have my 5 ordered pairs. Let me see if that's enough to get the general graph here. Now, like always, I'm going to label my x and y axes. So that's the first thing I want to do. Okay. Now, when I'm looking at this, I can pick whatever kind of scale I want for the x's and the y's. And just taking a look, these numbers aren't that big. I'm only going from -2 to 2 in the x direction, and it looks like I'm going from -4 to 0 in the y direction. So that doesn't seem that bad. I'm actually, just to show you a different way of doing this, I'm going to make each square half a unit. So what I mean by that is I'm going to go 1, 2, 3, oops, let me get it, 4, 5. So I'm just going to make it a little bit more spread out than it was initially. So we'll go 5, 4, 3, 2, 1, like that. All right, so let me put my markers in. All right, so here we go. My first ordered pair is -2, 0. And then I have -1, -3. And then I have 0, -4. And then I have 1, -3, and 2, 0. So I can actually see the parabola presenting itself here. Okay. Fantastic. All right, now just again to review this. All right, we're not officially picking up domain and range yet, but I do want to review the idea just to start to jog the memory. So if I was going to say domain and I was going to say range, okay, when you hear domain, think x coordinates and go left to right. So go left to right. When you hear range, think y coordinates, go down to up. Okay, so left to right for domain, down to up for range. So we're going low to high, low to high. All right, so here we go. If I look left, I can see that this arrow is heading left forever, and this one's going right forever. So as I move left to right, I hit the whole gamut. I'm going to go -infinity to infinity. But for range, in terms of down to up, you can see that both of my arrows are heading up. I don't have one heading down like I did in the previous example when we had the line. You can see the lowest y value I hit is -4. Okay, this was the y coordinate of -4. So my lowest y value is -4, and you can see that that arrow is heading up forever. So I'm going to get a range of -4, excuse me, to infinity. Okay. All right. So with that, let's take a look at C. I tried to change things up a little bit in part C. So let's make sure we got this one under our belt. So where I tried to change things up in part C is that I didn't have y defined in terms of x. You can now see I have x equaling a y function, right? So y is now our independent variable, which is why I listed it first. So I'm going to try my standard ones. I'm going to do -2, -1, 0, 1, and 2. And we're going to run into some problems, and then we're going to adjust. Okay? So let's take a look. I tried -2. I plug that in for y. Well, -2 minus 1 is -3. And I can't take the square root of -3. So I'm going to write dne here. And when you hear me, or when you see me write dne, that stands for does not exist. We can't take the square root of a negative number, at least over the real numbers. We have imaginary numbers, but we want to graph real ones right now. All right, so if I plug in -1, a y value of -1, well, -1 minus 1 is -2. That also would be a dne. Right? If I plug in 0, 0 minus 1 would be a negative number. All right, that would still be, I can't square root it, a dne. If I plug 1 in, I finally get a number I can use. 1 minus 1 is 0. The square root of 0 is 0. Okay, I can use that. All right, 2. Well, 2 minus 1 is 1. The square root of 1 is 1. Okay, great. Let's take a look at what we have so far and see if that's enough to make the graph. You want to be careful, all right? We picked our y values because this time y was our independent variable and x depended on y. But we still need to write our ordered pairs up, x comma y. So be real careful when you have x defined in terms of y. We're very used to y equals something. This is an x equals. So this would be the ordered pair 1, 2. So let's see what we got. So we got 0, 1, 1, 2. All right, now as I'm looking at this, I'm going to go ahead and graph x against y. I don't know how large my numbers are about to get. I only have these 2 dots. That's really not enough for me to understand what's happening with the graph. So I'm going to set these at 10 and 10 in case my numbers get too much larger. So at this point, I hope you're starting to feel we have to take the square roots of numbers. So start to pick numbers that are advantageous to you. And here's what I mean. You could pick 3, all right? And we could do 3 minus 1 is 2. And this would be the square root of 2. but that's not a nice exact number. So again, pick numbers that make your life a little bit easier. Let's be more efficient. So I would like my radicand, all the stuff under the radical, to be a perfect square, right? So what would be a great x coordinate to pick? And I'll help you out here. I'm going to pick 5, and maybe you'll see in a moment why I'm going to pick 5. If I do 5 minus 1, that's 4, and the square root of 4 is a nice number like 2. So again, I want to pick numbers that make my life a little bit easier. Now again, be careful. We want to graph the point 2 comma 5. So I'll go 2, and then I'll get to 5. All right, so let's think, even though I ran out of space, I'm going to extend this for just a bit. What would be the next number I want to pick? What would be a nice number to have under that radicand? Well, I would like a 9 to be under there because the square root of 9 is a nice number. If I want y minus 1 to equal 9, then y should equal 10. And when I plug 10 in, 10 minus 1 is 9. The square root of 9 is 3. And that's going to tell me I have the ordered pair 3, 10. So let's head over there. And when I get my 3, 10 that I'm taking a look at, well, then I can start to see this graph. Okay. And before we finish this one off, let's just practice the domain and range one more time. All right, so domain is always left, right. Range is always down, up. So left, right. If I look here, my leftmost point is right here. And the x-coordinate of that leftmost point was 0. So my domain starts at 0. And you can see that right arrow, or that arrow is going up and right forever. So I'll think about the right part of things because domain is left to right. If it's going right forever, it's going to give me an infinity. All right, range is low to high. So I look at my lowest point, it's right here again at 0, 1, but this time I want the y-coordinate because I'm looking at the range. So I'm going to go ahead and say, well, my y's start at 1, and again, you can see it going up forever. Anytime I hear the word forever with those arrows, they're going to turn into infinities, right? So this is going, if I want to write this out, this was right forever and up forever. And I guess I'm dating myself, but back in the 90s in our high school yearbooks, we would write like, you'll be my best friend forever. So that's what I mean by forever. So this arrow here is going, if I was going to draw it, it's going to the right and it's going up forever. So that right forever is going to turn into a positive infinity, and that up forever turns into a positive infinity, respectively on the domain and on the range. All right, so with that, I'm going to flip over to my graphing calculator and I'm going to show you how you can graph these, at least parts A and B, on your graphing calculator, and we'll get used to graphing things on that. All right, I'll see you in a few. Bye.